Welcome to Tomorrow's World Today, a show dedicated to the discovery of innovation and cutting-edge technology to be featured in the Park of the Future. The park includes 4 worlds. The worlds are inspiration, creation, innovation, and production. Each one will showcase the latest developments from the greatest companies and smartest people in the world. This is Inventionland World Headquarters. Here now is George Davison.
You know, it's so exciting to be able to design a park of the future. There are a lot of challenges. Solar looks like it's going to play a role, that's for sure. Natural gas is also going to be something that we're going to have to look a little further into. It's plentiful. It's also a clean burning fuel. We have 300,000 miles of pipeline in the United States that's carrying natural gas. That's amazing from many different directions. But this is a technology right here. They call this a liquid natural gas, or an LNG train. What's interesting about it is that they actually chill it down to negative 260 degrees to turn the gaseous form of natural gas into a liquid. So a lot of technology here. We're gonna need to really get this understood. Hey, Tamara, I need you to pack your bags and go on another journey to go figure out if natural gas is gonna be the next thing for us.
All right, boss, I'm on it. I'll start with the extraction site, follow the pipeline down until I get to the shipping point so that we can learn about the whole process. Anything I need to know about this in particular?
Yes, you're gonna need boots and a parka.
You always send me to the best places.
I've seen many a delicate flower winter a day or two in the snow. So yes, you're off to see the snow. So have fun.
All right, I'll bundle up.
Super. I'll see you when you're back.
One of the things that I love about my job is that I get to travel far and wide looking for the best options for our park of the future. And today, my journeys have brought me to a mountaintop in West Virginia. We've been looking for the right energy sources for the park. Natural gas keeps popping up. I'm here today at a production site run by Southwestern Energy. My friends there have loaned me some trendy safety gear, which luckily for me is also warm because I don't know if you can see it, but it's snowing here. Natural gas is being used more and more in our world. It's a natural source of power that can feed electric cars, as well as power plants, our cooking appliances, air conditioners, big semis, and mass transit. Natural gas is formed when decomposing plant and animal matter and other organic materials are buried deep beneath the earth. There, they're exposed to intense heat and pressure over millions of years. The gas becomes trapped within the rocks, which seals it away deep beneath the surface. Conventional natural gas can be extracted through drilling wells, but unconventional forms such as coal bed methane, methane hydrates, tight sandstone, and shale gas have specific extraction techniques. The Energy Information Administration estimates that by 2035, 46% of the United States gas supply will come from a gas called shale gas, which is the kind of extraction site I'm on right now. Shale gas is extracted today through a process known as hydraulic fracturing. A hydraulic drilling rig is built above the shale gas formation down below. After being inspected for U.S. safety regulations, the drill bores deep into the earth as layers of cement and steel casing are laid to create an impermeable barrier between the well and the groundwater. The hole drills vertically until just before reaching the shale bed. At this point, the drill begins to slowly turn horizontally until it runs through the shale bed. Another cement casing is made, followed by a perforating device, which makes small holes in the casing and rock. Finally, a fluid comprised of water, sand, and chemicals is pumped down into the well bore, which creates tiny hairline fractures. The natural gas is allowed to flow into the casing and up the well bore, where it is then collected. The entire process from start to finish can take from 3 to 5 months, depending on the length of the well. After extraction, this gas is going to travel 15 miles to a collection point, then onto a gas plant for more processing to prep it for the pipeline. Once it gets into the pipeline, it'll travel all the way from here in West Virginia to Cheniere's liquid natural gas plant in Louisiana, which will prep it for export. Which means I'm heading south to follow the pipeline. So how do you get natural gas from the shale bed to the terminal? Well, with over 300,000 miles of pipeline in the United States, that answer is pretty simple. This huge network of pipelines connects the drilling sites to treatment plants and processing facilities in different cities, states, and even countries. In fact, sometimes it even delivers the product directly to the consumer. Where I'm standing right now, there's 20 miles of brand spanking new pipeline connecting me to the new LNG transfer plant. I have so many questions about this pipeline, which is why I am really glad that Corey Grindle from Cheniere is here to help answer some of them.
Hi, Tamara, how are you?
I'm good. My very first question is about how much gas can flow through one of these pipes in any given day.
These pipes are flowing about 1.3 to 1.4 BCF a day, which is billion cubic feet. So our Sabine Pass currently is producing about 3.2 BCF a day, which is just under 5% of all the gas that's produced in the United States.
So what are the advantages to moving natural gas through a pipeline system such as this as opposed to other modes of transport?
When gas moves through a pipeline, it's extremely efficient. All along these pipes, you'll see these transmitters. What they do is they monitor pressure and they monitor temperature, they monitor flow, and they will send a signal back to a computer.
And I would imagine that feeds back into the safety factor.
It feeds back into the safety factor. It feeds back into a much larger evaluation process where you're not only looking at these transmitters, but you're looking at the whole facility as a whole and running it all safely.
Well, next stop, the Sabine Pass plant. Here we go. I am standing here in front of what I like to think of as one of the world's biggest thermoses. But this storage tank is way more than just a container. It is a technological wonder, and it's one of many that we're gonna see here on tour today. So 20 miles, and here we are.
Welcome to our Sabine Pass facility. We are located at the mouth of the Sabine River, which is the border between Texas and Louisiana.
So if you straddled the river, you'd have a foot on each side?
If you had a very wide straddle, so what you see right behind us here is one of the trains. What happens is we take gas at the pipeline temperature of about 75 or 80 degrees Fahrenheit. We cool the gas down to 260 degrees below zero, which is where methane goes from being a gas to being a liquid.
Why are they called trains?
The term actually came from the railroad days. They were the facilities that would load a train's car, just like this is one of the facilities we use to process the gas and put it on the tankers.
So it sounds like I'm finally gonna get to see some liquid natural gas. What does LNG actually look like?
When you see LNG in its liquid form, it essentially looks like a cup of water. While you're here at Sabine Pass, we're gonna show you a miniaturized version of how LNG is made, and you'll get to see it for yourself.
Oh, cool. Well, I'm excited to go see the plant.
Awesome. Look forward to showing it to you.
So this is massive. I did not expect the train to look like this.
They are big. If you look behind us, the whole length of one of these trains is about 3.5 football fields long. And that's just one of the trains. Remember, we have 5 here at our Sabine Pass facility. It's 1,100 acres, the total size of the facility, and we do generate our own power on site.
One of George's ideas was that perhaps LNG could be used to power his park of the future.
One of the reasons why natural gas is so great for generation, when you look at an environmental standpoint, you'll always have solar and hydroelectric, wind technology. The problem with all those technologies is they're fairly intermittent. So you have to have another type of generation, another type of fuel source to back them up.
That's what George was saying. He was thinking that perhaps natural gas and renewable sources could be complementary to one another.
George is a smart guy.
Hey, don't say that too loudly. We don't want it to go to his head. At standard atmospheric conditions, methane, or natural gas, is a vapor. But before it can make that long journey overseas, it has to be converted into liquid natural gas, or LNG, which is a very cool process. Cheniere is using state-of-the-art technology, which has been developed over the last 5 years, to freeze and load LNG onto their ships. Evan, who is LNG's ambassador, is here to give us an inside look at the process.
Basically, what you're seeing here is what we see on the plant, just a lot smaller and simpler. Right here in this tank, you have LNG. When natural gas is in a standard form, it's just vapor. It's literally boiling off, it's evaporating, and when we're finished, we'll have a glass of water that you can drink. If you want to pick yours up, and say cheers.
Cheers.
There you go.
I'm very surprised. It's nice to know this works.
Yeah, it does.
I don't know if I could get George to try it, but I might have to try.
Okay, I'll be there if you need it.
All right, I might count on you for support.
Okay, but you can do some other things that are pretty cool to show how safe LNG actually is.
Are we gonna make s'mores?
Just dip the little edge in. You can actually see it burn off.
Oh, yeah.
If you want to. It's a little cold, but you can take a bite.
Oh, yeah, it tastes like it's been in the fridge.
Now let me show you something really cool. So racquetball, normally bouncy, but put it in LNG at negative 260 degrees.
Uh-huh.
No longer bouncy, binky. Makes it bink.
I was wondering what a racquetball had to do with LNG, but
Yeah.
this is the freezing process.
Well, this is really what we do is we take something that's at a high temperature, put it at a low temperature. Now let me show you another one.
A flower for me?
Well, not really, for science.
All for science.
Put it in the LNG at negative 260 degrees, and a rose by any other name wouldn't crumble quite the same.
Oh my God, that is so cool.
And this really shows you how really cold it is.
My dad would kill me if I did this to his rose garden, but this is really neat. All right, let's head to the ship so we can see it in action. But first I'm gonna finish my snack. When it comes to LNG, it's all about the shipping and cooling process. So I'm here with Marine Manager Stephen Mills, who's going to give us the rundown on how they supercool large amounts of natural gas into LNG for shipping. What exactly has to happen to the LNG to prepare it for shipping?
Earlier, I think you saw on the trains how they cooled it down. We took gas and they made it into a liquid. Once it gets into a liquid, it's put into our tanks. From the tanks, we're using high pressure pumps now. We're running through the piping system that you saw as you were coming down. As the ship is now alongside, we're blending our two technologies together, and we're actually sending the liquid through the piping system and into the ship. We do a lot of checks, a lot of safety systems are put in place to make sure it's safe to transfer this cryogenic liquid. The control room here on the ship, along with our controllers, are controlling the flow of liquid into the ship to keep everything on a nice, safe process.
Well, it sounds pretty intricate. How long does it actually take to fill the entire ship?
Typically, on a ship this size, about 170,000 cubic meters, which is about the equivalent of 3.8 billion cubic feet of gas. We can put about 15 hours once we get up to a full rate and load the ship.
So what exactly are the benefits of shipping liquid natural gas, LNG, as opposed to just natural gas in its vapor state?
1 cubic meter of liquid would equal 612 cubic meters, approximately, of natural gas. So it's a lot more efficient, and you can get a lot more on a ship than you could if it was in a gas state.
And is it true that liquid natural gas is actually lighter than air?
That's correct. And in a liquid state, if it were to get into the water system, it would rapidly vaporize, and the vapor is lighter than air and would rise higher than the surface. That's one thing about natural gas. It is a non-pollutant.
The ship is pretty massive, as we've seen. What kind of ports can this ship actually go into?
Well, every LNG terminal is specific built for these type of vessels. So it can't just go into a standard port, a wharf. It has to be specifically designed for LNG, but these ships go worldwide.
Steve, thank you so much for going through the process with me. It was really nice to meet you.
Thank you.
I just got off the ship, which is massive and amazing, and now I want to know more about what happens after it leaves the port. Well, Evan was really hospitable. He gave me a drink of water, he gave me roses. Now I want him to give me an explanation about what happens to the LNG next. So I was just on one of the ships.
Yeah.
Incredible.
Yes.
What happens after it leaves the port?
So these ships go all over the world, 5 continents, hundreds of cargoes, dozens of countries around the world that can take LNG. And that's where it gets warmed back up, made into natural gas, and then you can use it for whatever you want, electricity, industry, heating, etc.
And why is it that the Asian market has seen such an expansion over the last couple of years?
So those are countries that really want to both expand their economy and protect their environment. The good thing about natural gas is it can do both. It can really give electricity to places that don't have it or need more of it, but it can do it without the mercury pollution, the smog, all the things that cause people to have respiratory illnesses, or even mercury that can get in your fish and then get into your system. And because of the resources that we found here in the United States, the cost of natural gas here has really dropped. That means we're not just competitive here in the United States, but we're competitive worldwide. And that's why you're seeing such a demand.
Natural gas and solar can be complementary, right?
What natural gas and solar do well is they work together. You have the intermittency of solar. The sun's not always shining. and you have the reliability of natural gas. You put those two things together and you really have an energy system that works all the time, reliably and sustainably.
This natural gas has come a long way to get here. It's been through compression, it's been pressure pushed, and now it's been turned from vapor to compact liquid. But even after all this processing and after the LNG gets loaded onto the ship, it's got a long trip to Asia.
Hey, George.
Hey, Tamara, how are you doing down there?
I've been telling people down here that I think your hunch was right. It looks like natural gas is a strong complement to solar as an energy source.
That is the best news I've heard today. Way to go, Tamara.
You know, the ships down here are massive. It's pretty incredible to see. Do you know how much LNG one of these Cheniere ships can hold?
I have no idea how much.
Enough LNG to power approximately 40,000 U.S. homes.
40,000 U.S. homes. For how long?
About a year.
A whole year?
Yep.
That's some great technology then.
Well, with all the technology that you've been talking about deploying in the park, boilers, generators, all the innovative stuff, I think that natural gas definitely has a part to play.
You know what?
What?
That would probably translate to one shipload to power our park for a year.
Well, if you want to get into the particulars, I was talking with one of the guys down here, and he said he'd be willing to come up and talk over what might specifically work for our Park of the Future.
Please send him. I'll have a boatload of questions for him, I'm sure. Start packing your bags, jump on a plane, and get back here.
Aye, aye, sir.
So one of the big challenges we're going to have in building our Park of the Future is figuring out how to power it. Now, Tamara's been down in Louisiana, and she's been trying to figure out the power situation with a company called Cheniere. And one of the executives is coming up to see us today. You must be Evan.
You must be George. Nice to meet you.
I hear you're doing some innovative things down there at Cheniere.
Yeah, I hear you're the innovation guy.
Well, we're getting ready to design and build a Park of the Future. We have 4 worlds in our park. We have the world of inspiration, the world of creation, the world of innovation, and the world of production. And the power we're going to need is going to be substantial. The type of energy we use is very important to us. We would like to put as little footprint on the earth and be as sustainable, as clean as we can. Can you speak to that a little bit?
All of our customers at Cheniere are countries and companies around the world. And they're looking to power their economies, but they're also looking to lower air pollution, fight climate change, and do whatever they can to have a lower environmental footprint.
I take it your business is growing right now, because I think the world's moving in that direction, and we'd like to move with it in that direction as well.
Exports of United States LNG only just started in February of 2016. But you have a lot of countries around the world, China, for example, 45% over last year in terms of how much LNG they've brought in. We think it's going to get bigger and bigger and bigger as more people access it.
So how about your workforce? Do you have the talent you need, or do we need to bring more kids up in your field?
We need more kids who are in STEM, who are learning engineering, learning about physics and energy. Those are the people we really want.
How are you with the cold? It's kind of blowing snow, I hear, out there right now.
Yeah, well, I'm a New Englander, so I'm okay.
I was hoping that maybe we could go out and do a little site visit. You could take a look at what we're up to and run some ideas by me as to what you think we could do.
Sounds great. Love to see it.
All right, let's go brave it then.
Okay. LNG, coming from the United States, is about as innovative as you get in energy these days. As long as that snow isn't negative 260 degrees, like LNG, I'll trudge through anything to see the site for the Park of the Future.
Well, we're pretty excited about this big park we're building.
Yeah.
So, you know, this is what we're dealing with. We're going to need a lot of gas.
Wow. Yeah, no, you're gonna need a lot, especially on a day like this. Clouds are out. How are you gonna power everything?
Well, you're right. Every once in a while, we've got, you know, the full sun going, but we're going to need a reliable, green, sustainable source of energy. For all these creative activities and rides that are going to go on, I can't go down. The park has to be at full capacity at all times.
Sure, and that's a really great thing about pairing renewables with natural gas. On days when it's really sunny or really windy, you might get a lot of energy from that, but what about the days when it's not? And that's when natural gas can really spin up the power really fast, much faster than coal or nuclear or something else that's dirtier or slower to get online. But it's also reliable. You're not gonna have any rides go down as long as you have those two things paired together very well.
So Evan, let's recap. It's clean, plentiful, and reliable. Sounds perfect for our Park of the Future. What do you say we get up off this cold hill, huh?
Yeah, I'm with you.
Let's go.
Well, I think the park of the future really reflects where we're going here at Cheniere, and that's into a future energy system that's cleaner, more sustainable, more reliable, and we're really excited about it.
So tomorrow, you've had a busy week.
You had me earning my frequent flyer points this week, George.
Well, you went off to West Virginia. You got to see how gas was extracted.
That's right. It was really interesting to see where the whole process starts. And it was snowy and cold.
But then you got to follow the pipeline south.
Yes, it definitely heated up as I went, and then I got to continue all the way to the endpoint at Cheniere in Louisiana. I was really amazed by just the size of the trains that they had to process the natural gas and turn it into that liquid natural gas, which then got loaded on the ships. It was massive.
Maybe one day we could just take the park and put it right on top of one of those ships, and we could just take it around the world. We'd have all the natural gas we'd ever need.
Wait a minute, are you now planning a cruise line for tomorrow's world today?
Why not?
Let's get our mobile park set, then we'll go cruise line, and then space station.
Why not? We're in creative mode.
All right, boss, I am heading home.
Oh, not so fast.
Where am I going instead?
Honduras.
When?
Right now.